Namaskar friends, I Puram Dogra on the behalf of Vichitra Enterprises welcome you all and hope you all are doing very well. Now friends, continuing the topic of energy audits, today we are going to cover a very interesting topic in energy audit, that is we will see the case studies and after energy audit, that how a particular case have given us the energy conservation and how much ROI, return on investment, was there. We will see the calculations also. So let's see. Now coming to the case study. So we'll do a case study of a chiller. Here you can see this is the chiller which was present in our site, which was a commercial building. It was a mall. So this was an old chiller. It was like 20 to 25-year old. So as it was old, here you can see these are the compressor. These are cylindrical type compressor. Nowadays screw type compressor is being used mainly in chillers. So I'll give you the details of this, and before going to that, let me give you a brief of what is chiller. So chiller is the main component or a main part of HVAC, heating, ventilation, air conditioning system in a building, or we can say it is a main component of a centralized AC system. It is water cooled chiller. So water comes in from here and goes out from this pipe, and the water coming out from AHUs, air handling unit, which are placed in every floor for giving cooling to the floor, or for giving cool air to the floor. How the cool water from this chiller goes to every AHU, and the system, the whole buildings get cooled. So here these compressors will work, and refrigerant we have in this system, in this chiller system only. So the hot water from the floors will get cooled here and will again circulated to the AHUs. So this is a general like cycle of a chiller, and I'll give you this chiller cycle in details in some another video. Here you can see this is a chiller only. Okay, now this old chiller was taking high IKW, which means that for 1 ton of refrigeration it was taking 1.6 kilowatt of energy, or 1 kilowatt, 1.6 kilowatt, 1.6 units per hour for cooling 1 ton of refrigeration for 1 TR. So it is high. You can see that now I'll compare it with the with ACs which we use in our households. So for 1 TR, 1 ton refrigeration, or 1 ton AC, the energy used is approx 1200 watt. Okay, or 1.2 kilowatt we can say, or it can be 1.5 kilowatt also for low star rated ACs. But here this chiller system have other components also, which like pumps are also there, AHUs are also there. So the complete system, the complete chilling system will consume more power if the chiller only is consuming 1.6 kilowatt for 1 TR. So what is the ideal case? We'll see in the next slide. Now this is a new chiller. Here you can see no cylindrical compressors are there. This is a screw type compressor, and this is more energy efficient. It's like insulation is very closed, and the system is also more automatic than the previous one because this is a new chiller. So the IKW, or specific power consumption of a new energy efficient chiller, is zero point 0.5 to 0.7 kilowatt per ton of refrigeration. So this is the IKW for an efficient or a new water cooled chiller. For different kinds of chiller, it is different. Like we have air cooled chiller also, we have magnetic type chillers also, and we have this water cooled chiller. So for water cooled chiller, it is 0.5 to 0.7 kilowatt per TR. Now going to the ROI calculation now. So here we have the ROI calculation for replacing that old chiller with a new energy efficient chiller. So if we recommend our customers, our clients, with a new energy efficient chiller, that the old one is to be replaced with a new one, so we have to get this ROI calculation. Now you will see that what will be the actual benefit to the client, or how much energy they were losing because of this old chiller. Okay, so present power consumption for the chiller, this was a 270 ton refrigeration, 270 TR chiller, each with, so there were two chillers, so we were giving this for a single one only. IKW 1.6 running at 80% loading. So with 1.6 IKW, this chiller at 80% loading was consuming 275.6 kilowatt per hour. Okay, now average power consumption with new chiller of same capacity, we have taken IKW 0.7. The range was from 0.5 to 0.7, but we are taking 0.7 at a higher end. So the new kilowatt for the same chiller will be 189 kilowatt, 189 units per hour. Expected reduction in power in kilowatt will minus this, the old one minus new one, 86. So per hour 86 units can be saved. Average operating hours in a day are 12. Yeah. The chiller was running from 10 a.m. to 10 p.m. so 12 hours. Annual operating hours, let's say the chiller operates for 300 days only, because in January and in December we won't run this chiller, will not run this chiller, but most of the days in Delhi we use chillers. So the operating hours were 3600, 12 into 300, 3600. Now annual energy saving, the annual energy saving in kilowatt will be 309,600, 3,09,600 hours, kilowatt hour. This is by multiplying 3600 into 86. Annual cost saving at the rupees 10 per unit. So friends, you can see that how much uh, cost can be saved by doing an energy audit, or you can say by doing this replacement. So here you can see this is 30 lakh 9,600 annually. can be saved by using a new chiller, by replacing a new chiller. Yes, the investment will be there. So let's say the investment made for procuring this chiller is 81 lakh. Okay, so it can be higher or lower. I'm not going much deeper into this chiller cost calculation or chiller make and the cost of that make. So it is approximate. It will take around this much, 81 lakh of investment. Now simple payback period for this chiller is 32 months. Only 32 months. And after that you can save this much of energy annually, this much of energy, 3,09,600 units annually. Reduction is, now talking about the CO2 reduction, for India we take 0.82 kg CO2 per kilowatt hour. This is the average in India, because most of the energy is being generated by coal, and coal is also not very uh, good in India. But the average CO2 emission reduction calculation, the average for the world is around 0.45, 0.5, but in India it is 0.82. So I'll calculate with that. And the CO2 reduction for this case study is 253.872 ton per year, or 2,53,872 kg per year. So you can see how much effect a small replacement can do in a building. And if we go through the energy audit, complete energy audit of the building, many of the equipments were not working in their good efficiency. Like pumps were not very efficient, because the whole building was 20 years old and the whole equipments were that old only. So the pumps were not good, the cooling tower was not working properly, and many of the STP pumps and WTP pumps, motors and blowers were old only. So you can see an immense energy can be saved there, and there is a potential of saving a lot of unit, a lot of uh, cost saving and CO2 saving. So this is a case study, and how you find topics you want to see next videos. So friends, this is it with this case study. How you find this video, please do comment below, and if you have any queries, any suggestions, do comment. And friends, if you like my videos, if you like to view these technical videos, please do subscribe my channel and share it with your friends. See you in the next video. Till then, bye bye. Thank you for watching.